Interpretation of acid-base disorder Part 4, Exercise. Dr. Jalal Mohsin Uddin. MBBS, DTCD. FCPS Pulmonology. Exercise 1. ABG report. pH 7.69. PCO2 30 mm of Hg. HCO3 bicarbonate 35 milliequivalent per liter. NS sodium 134 millimole per liter. K potassium 4.0 millimole per liter. Cl chloride 84 millimole per liter. Anion gap 15 milliequivalent per liter. Question. 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 1. 1. We consider that the report is internally consistent. 2. At first we should look at the pH. It is more than 7.45, so it is a case of alkalosis. 3. Then we look at the PCO2. There is washout of CO2 as it is even lower than 35 mm of Hg. And it is consistent with pH. So it is a case of respiratory alkalosis. 4. If there is only compensation, there should be lowering of HCO3, bicarbonate, and direction of change of PCO2 and HCO3 bicarbonate should be in same direction if it would be simple disorder, but here change of HCO3, bicarbonate, in opposite direction. So there is metabolic alkalosis, as HCO3 bicarbonate is more than 29 milliequivalent per liter. 5. So it is a case of respiratory alkalosis with metabolic alkalosis. 6. There may be some differential diagnosis. LVF treated with diuretics. LL. Pneumonia associated with vomiting. Remark. In case of mixed disorder there is no need for evaluation of the type of respiratory acidosis, acute or chronic. Exercise 2. ABG report. pH 7.44. PCO2 55 mm of Hg. HCO3 bicarbonate 36 milliequivalent per liter. NS sodium 135 millimole per liter. K potassium 3.8 millimole per liter. Cl chloride 84 millimole per liter. Anion gap 15 milliequivalent per liter. Question. 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 2. 1. The pH is within normal limit and it is nearer to upper level. 2. The level of pH does not match with PCO2 level. There is increase of HCO3 bicarbonate level. So it is a case of metabolic alkalosis. 3. Due to compensatory mechanism, PCO2 must be increased. Here PCO2 rises to 55 m of Hg. 4. To check the limit of the compensation and to investigate the presence of associated respiratory acidosis, we have to apply Summers' equation. 5. PCO2 equals 36 multiply 0.9 plus 9 plus minus 2. Equals 32.4 plus 9 plus minus 2. Equals 41.4 plus minus 2. Equals 39.4 to 43.4, it should be the maximum PCO2 level. 6. But here the PCO2 level is 55. So there is associated respiratory acidosis. 7. It is a case of metabolic alkalosis with respiratory acidosis. 8. There is some differential diagnosis. 1. COPD with pulmonale treated with diuretics. 2. Acute exacerbation of COPD with persistent vomiting. Exercise 3. ABG report. pH 7.43. PCO2 39 mm of Hg. HCO3 or bicarbonate 25 milliequivalent per liter. Na or sodium 132 millimole per liter. K or potassium 3.7 millimole per liter. Cl or chloride 84 millimole per liter. Anion gap 23 milliequivalent per liter. Question. 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 3. 1. Here pH, PCO2 and HCO3 or bicarbonate are within normal limit. Only abnormality is the high anion gap 23. That indicates high anion gap metabolic acidosis. 2. Though there is presence of high anion gap metabolic acidosis, still pH is normal. It indicates presence of mixed disorder. 3. Delta anion gap equals 23 minus 12 equals 11 and delta HCO3 or bicarbonate equals 22 minus 25 equals minus 3. 4. So, delta anion gap is greater than HCO3 or bicarbonate. It indicates there is presence of metabolic alkalosis with high anion gap metabolic acidosis. 5. When the metabolic acidosis there should be compensatory decrease of PCO2. According to the Winter's equation expected. PCO2 equals 1.5 multiply 25 plus 8 plus minus 2 equals 37.5 plus 8 plus minus 2 equals 45.5 plus minus 2 equals 43.2 to 47, minimum level of CO2 due to compensation. 6. Still the PCO2 is further lowered, 39 mm of Hg. Here PCO2 has further decreased due to presence of respiratory alkalosis. 7. So it is a case of metabolic acidosis, metabolic alkalosis with respiratory alkalosis. 8. Example of this triple disorder, pneumonia leading to septic shock with nasogastric suction. Exercise 4. ABG report. pH 7.12. PCO2 16 mm of Hg. HCO3 or bicarbonate 5 milliequivalent per liter. Na or sodium 137 millimole per liter. K or potassium 3.6 millimole per liter. Cl or chloride 114 millimole per liter. Anion gap 18 milliequivalent per liter. Question. 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 4. 1. Here pH has decreased, so it is a case of acidosis, which is consistent with low HCO3 or bicarbonate level. So it is a case of metabolic acidosis. 2. As there is high anion gap, it is a high anion gap metabolic acidosis. 3. Here delta anion gap is 18 minus 12 equals 6 milliequivalent per liter and delta HCO3 or bicarbonate equals 22 minus 5 equals 17 milliequivalent per liter. 4. So delta HCO3 or bicarbonate is greater than delta anion gap. It indicates here normal anion gap is associated with high anion gap metabolic acidosis. 5. To us as the compensatory change we can apply Winter's equation. PCO2 equals 1.5 multiply 5 plus 8 plus minus 2 equals 6 plus 8 plus minus 2 equals 12 to 16, level of compensation, so compensation is within normal limit. Here there is no other disorder. 6. It is a case of high anion gap metabolic acidosis with normal anion gap metabolic acidosis. 7. It may be case of diabetic ketoacidosis with diarrhea. Exercise 5. ABG report. pH 7.43. PCO2 to 25 mm of Hg. HCO3 or bicarbonate, 16 milliequivalent per liter. Na or sodium, 135 millimole per liter. K or potassium, 3.2 millimole per liter. Cl or chloride, 91 millimole per liter. Anion gap, 28 milliequivalent per liter. Question. 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 5. 1. Though the pH is within normal limit, there is high anion gap, 28 milliequivalent per liter, which indicates presence of high anion gap metabolic acidosis. 2. The HCO3 or bicarbonate has lowered, which match with metabolic acidosis. 3. Delta anion gap is 28 minus 12 equals 16 milliequivalent per liter. And delta HCO3 or bicarbonate is 22 minus 16 equals 6. As delta anion gap is greater than the delta HCO3 or bicarbonate, so there is metabolic alkalosis. 4. To see the compensatory response we apply Winter's equation PCO2 equals 1.5 multiply 16, plus 8 plus minus 2 equals 24 plus 8 plus minus 2 equals 32 plus minus 2 equals 30 to 34, should be the compensatory change. 5. HCO3 or bicarbonate is still lower, so there is associated respiratory alkalosis. 6. The diagnosis may be congestive cardiac failure result pulmonary edema which leads to pulmonary hyperventilation plus shock leads to lactic acidosis plus treated by diuretics may lead to metabolic alkalosis. Exercise 6. ABG report. pH 7.22. PCO2 80 mm of Hg. HCO3 or bicarbonate 32 milliequivalent per liter. Na or sodium 141 millimole per liter. K or potassium 4.3 millimole per liter. Cl or chloride 99 millimole per liter. Anion gap 10 milliequivalent per liter. Question. 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 6. 1. pH is consistent with acidosis and it match with increased PCO2 level. So it is a case of respiratory acidosis. 2. Here pH equals 7.22 so concentration of H plus is 58, change of H plus is 58 minus 40. Equals 18. 3. Change of PCO2 is 80 minus 45, equals 35. 4. Change of H plus, divided by, change of CO2, equals 18 divided by 35 equals 0.51. Indicate acute on chronic respiratory acidosis. For each 10 unit change of PCO2 there will be change of 1 unit of HCO3 or bicarbonate. So for 35 unit change of PCO2 there will be change of HCO3 or bicarbonate. 5. So compensatory change in HCO3 or bicarbonate will be 28 plus 3.5 equals 31.5 which is very much consistent to the given level of HCO3 or bicarbonate which is 32 milliequivalent per liter. So there is no mixed disorder. It is an acute on chronic respiratory acidosis. 6. Acute exacerbation of COPD is a good example of in this condition. Exercise 7. ABG report. pH 7.61. PCO2 30 mm of Hg. PO2 70 mm of Hg, HCO3 or bicarbonate 29 milliequivalent per liter. Na or sodium 140 millimole per liter. K or potassium 3 millimole per liter. Cl or chloride 92 millimole per liter. Question 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 7. 1. pH is alkalotic and it match well with PaCO2. So it is a case of respiratory alkalosis. 2. Anion gap is, Na or sodium minus, Cl or chloride plus HCO3 or bicarbonate, equals, 140 minus, 92 plus 29, equals 140 minus 121 equals 19. High anion gap metabolic acidosis is present simultaneously. 3. Delta anion gap is, 19 minus 12, equals 7 and delta HCO3 or bicarbonate is, 22 minus 29, equals minus 7. 4. Here delta anion gap is larger than delta HCO3 or bicarbonate, so there is associated metabolic alkalosis. 5. There is no need to see the level of compensation. 6. There is no possibility to coexist respiratory acidosis as it cannot be present with respiratory alkalosis. 7. It is a triple disorder that is high anion gap metabolic acidosis with metabolic alkalosis and respiratory alkalosis. 8. Example include pneumonia with septic shock and vomiting. Exercise 8. ABG report. pH 7.22. PCO2 90 mm of Hg. PO2 66 mm of Hg. HCO3 or bicarbonate, 36 milliequivalent per liter. Na or sodium 140 millimole per liter. K or potassium 5 millimole per liter. Cl or chloride 94 millimole per liter. Question 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 8. 1. pH is acidotic and PCO2 match well with the feature. So it is a case of respiratory acidosis. 2. In 7.22 pH, H plus concentration is 62. Change in H plus, 62 minus 40, equals 22. 3. Change in PCO2 equals 45. So, 22 divided by 45, equals 0.5. So it is a case of acute on chronic respiratory acidosis. 4. In acute condition for each 10 mm of Hg of CO2 change there is change of 1 milliequivalent per liter. For 45 mm of Hg increase the change of HCO3 or bicarbonate 4.5. 5. With compensation HCO3 or bicarbonate should be 29 plus 4.5, equals 33.5. But here actual value of HCO3 or bicarbonate is 36. Here excess HCO3 or bicarbonate is due to metabolic alkalosis. 6. It is a case of acute respiratory acidosis with metabolic alkalosis. 7. There is no high anion gap metabolic acidosis. 8. Example, acute exacerbation of COPD with copulmonal treated by diuretic. Exercise 9. ABG report. pH 7.54. PCO2 44.9 mm of Hg. PO2 72.6 mm of Hg. HCO3 or bicarbonate 38 milliequivalent per liter. Na or sodium 145 millimole per liter. K or potassium 3.5 millimole per liter. Cl or chloride 98 millimole per liter. Question 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 9. 1. Here pH alkalotic and it match with HCO3 or bicarbonate level. So it is a case of metabolic alkalosis. 2. To see the compensatory response we can apply Summers' equation. PCO2 equals 0.9 multiply 38 plus 9 plus minus 2 equals 34.2 plus 9 plus minus 2 equals 43.2 plus minus 2 equals 41.2 to 45.2. Compensation is within the range, there is no mixed disorder. 3. It is a simple metabolic alkalosis may be due to persistent vomiting. Exercise 10. ABG report. pH 7.56. PCO2 15 mm of Hg. PO2 95 mm of Hg. HCO3 or bicarbonate 13 milliequivalent per liter. Na or sodium 140 millimole per liter. K or potassium 3.5 millimole per liter. Cl or chloride 107 millimole per liter. Question. 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 10. 1. pH alkalotic which match with the PCO2 level. There is presence of respiratory alkalosis. 2. Here anion gap is 140 minus 107 plus 13 equals 140 minus 120 equals 20. So there is high anion gap metabolic acidosis. 3. Here del2 anion gap and del2 HCO3 or bicarbonate is almost equal. Moreover, Winter's equation is also applied, showing associated respiratory alkalosis. 4. It is a case of high anion gap metabolic acidosis with respiratory alkalosis. 5. Example, diabetic ketoacidosis with community-acquired pneumonia. Exercise 11. ABG report. pH 7.30. PCO2 31 mm of Hg. PO2 91 mm of Hg. HCO3 or bicarbonate 15 milliequivalent per liter. Na or sodium 125 millimole per liter. K or potassium 3.5 millimole per liter. Cl or chloride 100 millimole per liter. Question. 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 11. 1. Here pH is acidotic and it match with HCO3 or bicarbonate. So it is a case of metabolic acidosis. 2. Here anion gap is 10, which is normal. Here it is a normal anion gap metabolic acidosis. 3. To see the compensatory response we can apply Winter's equation. PCO2 equals 1.5 multiply 15 plus 8 plus minus 2 equals 22.5 plus 8 plus minus 2 equals 30.5 plus minus 2 equals 28.5 to 32.5. Given value is within the range. So it is a simple normal anion gap metabolic acidosis. Example, diarrhea, renal tubular acidosis. Exercise 12. ABG report. pH 7.67. PCO2 30 mm of Hg. PO2 80 mm of Hg. HCO3 or bicarbonate 34 milliequivalent per liter. Na or sodium 140 millimole per liter. K or potassium 3.0 millimole per liter. Cl or chloride 94 millimole per liter. Question. 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 12. 1. The pH is alkalotic and it match with HCO3 or bicarbonate level, so it is a case of metabolic alkalosis. 2. To see the range of compensation we can apply Summers' equation. PCO2 equals 0.9 multiply 34 plus 9 plus minus 2 equals 30.6 plus 9 plus minus 2 equals 39.6 plus minus 2 equals 37.6 to 41.6, range of compensation. 3. But PCO2 is still lower, so there is concomitant respiratory alkalosis. 4. It is a case of metabolic alkalosis with respiratory alkalosis. 5. Example, acute LVF with diuretics. Exercise 13. ABG report. pH 7.33. PCO2 70 mm of Hg. PO2 55 mm of Hg. HCO3 or bicarbonate 36 milliequivalent per liter. Na or sodium 140 millimole per liter. K or potassium 4 millimole per liter. Cl or chloride 94 millimole per liter. Question. 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 13. 1. pH is acidotic and it match with PCO2 level, so it is a case of respiratory acidosis. 2. Change in H+, divided by change in CO2 equals 7 divided by 25 equals 0.28, which is less than 0.3, which indicate chronic disorder. 3. It is a case of chronic respiratory acidosis. 4. In chronic respiratory acidosis, for each 10 mm of Hg of PCO2 there is 3 milliequivalent per liter change of HCO3 or bicarbonate. So, for 25 mm of Hg the change will be 3 milliequivalent per liter multiply 2.5 equals 7.5 milliequivalent per liter. Expected HCO3 or bicarbonate should be 29 plus 7.5 equals 36.5 milliequivalent per liter, which is almost equal to given value. 5. Compensation is within the range, so there is no mixed disorder. It is a simple chronic respiratory acidosis. 6. It may be a case of COPD. Exercise 14. ABG report. pH 7.15. PCO2 50 mm of Hg. PO2 75 mm of Hg. HCO3 or bicarbonate 17 milliequivalent per liter. Na or sodium 140 millimole per liter. K or potassium 5 millimole per liter. Cl or chloride 103 millimole per liter. Question. 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 14. 1. pH is acidotic and it match well with HCO3 bicarbonate level. So there is metabolic acidosis. 2. Anion gap is high, 20 milliequivalent per liter. So it is an high anion gap metabolic acidosis. 3. To see the compensatory status, we can apply Winter's equation. PCO2 equals 1.5 multiply 17 plus 8 plus minus 2 equals 25.5 plus 8 plus minus 2 equals 33.5 plus minus 2 equals 31.5 to 35.5, maximum range of compensation. But PCO2 is much higher, so there is associated respiratory acidosis. 4. Here del2 anion gap and del2H, CO3 bicarbonate is almost equal. Here concomitant metabolic alkalosis absent. 5. So it is a case of high anion gap metabolic acidosis with respiratory acidosis. 6. It may be a case of diabetic ketoacidosis in COPD patient. Exercise 15. ABG report. pH 7.40. PCO2 40 mm of Hg. PO2 80 mm of Hg. HCO3 or bicarbonate 25 milliequivalent per liter. Na or sodium 140 millimole per liter. K or potassium 3.5 millimole per liter. Cl or chloride 95 millimole per liter. Question. 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 15. 1. Though pH is normal, but there is high anion gap 20 milliequivalent per liter. So it is a case of high anion gap metabolic acidosis. 2. To us as the compensation we can apply Winter's equation. PCO2 equals 1.5 multiply 25 plus 8 plus minus 2 equals 37.5 plus 8 plus minus 2 equals 45.5 plus minus 2 equals 43.5 to 47.5, but the present PCO2 level is much less than the limit. So there is associated respiratory alkalosis. 3. Del2 anion gap is 20 minus 12 equals 8 milliequivalent per liter, and del2H, CO3 or bicarbonate 22 minus 25 equals minus 3. Del2 anion gap is greater than del2H, CO3 or bicarbonate. It indicates that there is associated metabolic alkalosis. 4. It is a case of metabolic acidosis with metabolic alkalosis, and there is concomitant respiratory alkalosis. 5. Example, pneumonia with shock associated with vomiting. Exercise 16. ABG report. pH 7.11. PCO2 16 mm of Hg. PO2 85 mm of Hg. HCO3 or bicarbonate 5 milliequivalent per liter. Na or sodium 139 millimole per liter. K or potassium 4.0 millimole per liter. Cl or chloride 104 millimole per liter. SPO2 90. Question. 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 16. 1. pH is acidotic and it match with HCO3 level, so it is a case of metabolic acidosis. 2. Anion gap is high, 140 minus 104 plus 5 equals 140 minus 109 equals 21 milliequivalent per liter. 3. To see the compensatory response we can apply Winter's equation. PCO2 equals 1.5 multiply 5 plus 8 plus minus 2 equals 7.5 plus 8 plus minus 2 equals 15.5 plus minus 2 equals 13.5 to 17.5, the range compensation, PCO2 is within the range. 4. Moreover, del2 anion gap and del2H CO3 or bicarbonate is equal. Therefore there is no mixed disorder. 5. It is a case of high anion gap simple metabolic acidosis. 6. Examples, 1. Diabetic ketoacidosis, 2. Lactic acidosis, 3. Methanol poisoning, 4. Ethylene glycol poisoning, 5. Salicylate poisoning. Exercise 17. ABG report. pH 7.46. PCO2 25 mm of Hg, PO2 70 mm of Hg, HCO3 or bicarbonate 17 milliequivalent per liter, Na or sodium 140 millimole per liter, K or potassium 3.5 millimole per liter, Cl or chloride 107 millimole per liter. Question 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 17. 1. pH is slightly alkalotic, and it match well with PCO2 level. So there is presence of respiratory alkalosis. 2. As there is slight rise of pH, it indicates chronic respiratory disorder. So it is a case of chronic respiratory alkalosis. 3. In chronic respiratory alkalosis for 10 decrease of PCO2 there is decrease of 4HCO3 or bicarbonate. So for 20 mm of Hg decrease of PCO2 there should be decrease of 8 milliequivalent per liter HCO3 or bicarbonate. 4. After compensation the HCO3 or bicarbonate will be 24 minus 8 equals 16 milliequivalent per liter, almost equal to given value of HCO3 or bicarbonate. 5. An ion gap is normal. 6. So it is a case of simple chronic respiratory alkalosis. 7. Example, pregnancy, ILD. Exercise 18. ABG report. pH 7.49. PCO2 40 mm of Hg. PO2 75 mm of Hg. HCO3 or bicarbonate 35 milliequivalent per liter. Na or sodium 139 millimole per liter. K or potassium 3.0 millimole per liter. Cl or chloride 89 millimole per liter. Question 1. What type of acid-base disorder present in this ABG report? 2. How will you interpret the report? 3. What may be the underlying cause? How fast you can solve it? Answer with explanation. 18. 1. pH is alkalotic and it match with increase HCO3 or bicarbonate level. So it is a case of metabolic alkalosis. 2. To is compensatory response we can apply Summers equation. PCO2 equals 0.9 multiply 35 plus 9 plus minus 2 equals 31.5 plus 9 plus minus 2 equals 40.5 plus minus 2 equals 38.5 to 42.5. Level of compensation match with given PCO2. So there is no mixed disorder. So it is a case of simple metabolic alkalosis. 3. Example, use of diuretics, vomiting. Thank you all. End of exercise, part 4. Learning pulmonology.